welcome once again. I'll probably take 10 to 12 minutes in covering what I feel would be a very important topic on, energy efficiency versus air quality trade-off in Indian cities. It's a very interesting topic because we all are in the season where indoor air quality is at the top of the agenda. And while indoor air quality is at the top of the agenda, something we don't often talk about is energy efficiency, not in the same language as air quality, because there is always a trade-off. And I'm glad that we are going to discuss a little bit of it today. So before we get started, it's good to recap why are we talking about this. We all know how dangerous air pollution is. There is no need to elaborate on this. And as you can see in the slide, human body is designed in such a way that we can take care of the larger particles. We call them as the coarse particles. Human body is designed to manage those large particles to a certain extent. But then if we are prolonged, if we are exposed continuously to these coarse particles, then it may lead to, of course, complications. So when we say that the human body is designed to take care of the coarse particles, it doesn't mean that you can continuously be there. So intermittent exposures to coarse particles greater than 10 microns, that's that's the size of the particles we say. Human body is good enough to take care of that. As the particles get smaller, the body finds it difficult to manage them. Like the 2.5 micron particles, they settle into the lungs, and as they go smaller. The finer particles mixed with the bloodstream enter to the lungs, to the alveoli, and then transfers into the blood vessels. And as we know that the blood travels to the entire body, including critical parts like the brain and you name it, everywhere. And that's why we are talking about this today. We can see that how harmful air pollution can be. And there are alarming studies coming day by day. The latest one, which I read yesterday, was that air pollution can impact fertility. Now, that's something which a lot of people may not even think about. So air pollution can impact the human bodies in a different way. Fertility is something which at least I could not imagine, but that's what we are hearing now. And a lot of similar things which we don't even talk about. So that's why we are discussing this. And as we know, we are breathing air every day. We eat about 1 kg of food, drink an average human being drinks about 2 kgs of beverages, but we breathe about 15 kgs of air. And while the food and beverages we consume have a label on it, so we know the quality of the food we are eating and whatever we are drinking, but we do not know what we are breathing. At least there is no label on it. And the best part is that it comes free. So when it is free, you don't ask many questions, do you? So that's the important point, that we are breathing something which we don't know, and that's what is making us sick, especially in the current season. And we talk about air pollution only during these months when we all know that it's a year-round phenomenon. We are exposed to air pollution every single day of the year, 365 days a year. So there is no good time or bad time. There are relatively better times, I would say, but there is no good time. It's very rare if you have a good time. And now that we have spoken about the impacts of air pollution and the importance of it, we should also talk about the other part. At what cost does it come? What cost is air filtration? So we know that whenever we buy and own filters, we only focus on the initial cost. Why I'm talking about this is the topic is trade-off. What is the trade-off? At what cost are we preventing these air pollution issues? Well, if you see, the initial buy of a filter is only 10% of our total cost of ownership. It is the 80% which is the major villain, and that's what we are discussing about today. So that is the trade-off. You will get a good specified indoor air quality as per NACS, National Ambient Air Quality Standards, or as per WHO recommendations, but at an 80% cost, usually. And if you have to reduce that 80%, you will have to select the right air filter. And that's what we have to discuss and offer to the customer. How can we reduce that and still maintain that good and correct and specified indoor air quality? So, of course, when we talk about air pollution and energy trade-off, we should also talk about the applicable standards. So, right now there are two standards which primarily drive the air filters. One is the ASHRAE 52.2, and these are the standards for general ventilation filters, which are the ones who are contributing to positive indoor air quality. And then the first is the ASHRAE 52.2, which is predominantly an American standard. Then there is ISO 16890, which is predominantly an European standard or more a global standard. And then we have an equivalent of that ISO standard, which is the Indian standard, which has come out in 2021, which is 22. It is the IS 17570, which is a replica of the ISO standards. So right now we have two live standards according to which the air filters should be selected, tested, and used. There are a number of other standards, but all of them are obsolete. And when we are talking about air quality, it is important that we know what to use and how to use, how to select, how to test, etc., etc. So that's why this becomes very important, that people should be aware about what standards to follow. Because the prime job would be to get the efficiency right. The trade-off can come later. So the prime importance is to select the right product at the right efficiency levels, at the right airflows, so that you achieve the first objective, which is achieving the right efficiency up to the WHO standards or better. And then we talk about the second part, which is the trade-off. Now, how can we do it better? So that's what I am coming to now. I'll skip this one. So as we all know, in an HVAC system, it is the ducting, which is the number one energy guzzler, and number two is the air filters. So we have a lot of scope, even though the filters share in the entire, air handling unit value-wise is about 15%, whereas the AHU share, sorry, in a project is 15%, whereas a filter share by value in an air handling unit would be only 2 to 5%. So we are talking about a very small portion of something which is very big. But that small portion is the number two in the list of energy consumption items when it comes to HVAC thing. So it becomes very important that we discuss and address this issue. I'll take a couple of examples. We are taking two examples here. This is the energy consumption formula of two filters which are used for in a similar application. So left one, if you see the average pressure drop, Q is the airflow, which is same in both cases. Delta P is the average, is the pressure resistance across the filter. On the left hand side, it is 175 pascals, whereas on the right hand side, it is lower, it is 100 pascals, which means the example 2 is a better filter in terms of lower resistance to airflow. So obviously the pressure drop is lower. Keeping all the other parameters same, you can see that the energy consumption of the second filter is only 2000 kilowatt hour per year as compared to the first one, which is 3500 kilowatts hour per year. While both the filters may be doing the same impact, I mean, it would be of the same grade in terms of efficiency levels or filter grades or filtration capacities, the pressure drop is the trade-off. So that is how we decide which filter is better in terms of the trade-off. So obviously it's a no-brainer that filter 2 is better in this case, and that should be our endeavor, how to select the right filter. So extending the example, you have two filters, similar Filtration levels. Filter A is EPM 2.5, 50%. Filter C is EPM 1, 80%. So if you see, filter C is a better filter in terms of efficiency levels than filter A. So this filter A is filtering EPM 2.5 particles to an extent of 50%, whereas filter C is doing a better job. It is filtering a lower particle size of EPM 1 at a higher efficiency of 80% versus the 50%. And yet, if you see the pressure resistance across these filters, the lower efficiency filters has a higher pressure drop of 120 pascals, whereas the better filter in terms of efficiency has a pressure resistance of only 90 pascals. So despite being better in terms of efficiencies, the filter C is lower in terms of the pressure resistances, which in turn translates into energy consumptions. So this may surprise a lot of people, but there are options which are available now where we can actually trade off the efficiency in a better way and use better filters with lower energy consumptions. So a good air filters not only save energies, it's actually the whole air filter costs less. And nowadays we have very easy ways to identify, select if two filters are exactly the same, even costing the same. How do you decide which one to choose? Just go in for a Eurovent certified filter. That's the label which you see. You ensure that your filters are as per your selected criteria. In this case, it is EPM 160%. And if you see a label, you have an A plus grade filter. This is a 2019 filter, which means that this is the best filter you can get, one of the best filters. You can have different filters similar to this. Then you should go to the this particular figure. What is the annual energy consumption? In this case, it is 838 kilowatt hour per annum. So it's just like a BEE label. You filters also come with labels, and this is not company specific. It is a third party Eurovent certified product, and it is free for anyone to go and check before you actually can want to use a filter. Uh, this is a list of power consumptions of different filters which are available in the list in the bouquet. The good part is that there's only 1% filters, 1% of the whole lot, which is A plus, and this list is upgraded continuously, and it strives all the filtration companies to do better and remain in that 1%. So it's a good way to ensure continuous R&D and progress. Some ways where the filters can be made in a better way are like this. Uh, for a common man, a filter is a filter. There may not be too much difference if you see a filter, but just to give you more idea, when you select a filter, you should select a filter which can use the entire filtration area. In this case, this right side filter, which is a U-shaped pleat, is better than a conventional filter, which is a V-shaped pleat, because the dust is not entrapped completely in the filter, and it rests only on the superficial side. The example of the U-shaped filter is this. You can see a picture in the center of this filter. If you open the pleats, you can see that the dust is trapped right till the end of the pleat, and that is the example of a good air filter, which has a lower pressure drop and gives you a good trade-off versus the efficiency it achieves. Another example is a back filter. If you have a back filter, which is a conventional back filter U-shape, not a good design because the airflow from one pocket, obstructs the other one. The tapered stitch, which is on the above, that's a example of a better filter, which will consume less energy and result in a lower pressure drop, whereby achieving a similar efficiency levels. Last couple of slides. Just when we talk about trade-off, a lot of people asked how do you select a filter with a higher efficiency and claim that the energy consumption is less. Where I am just sharing a live case with you. If you see before, you can see that's an installation in Chennai, which is an office complex, I would say. Centralized air handling unit system. On the left is before. Um, You can see different types of filters, not proper orientation, disoriented pleats, not looking very good. You upgraded it, you can see the terminology is wrong. This should be after. And after, you can see we have increased the area, the depth of the filter. We have added a new frame, and then there is additional another stage of filter is added. Here you have a first stage of EPM 10 filters, washable only. Here we have added an EPM 2.5 filter, of course, to help customer achieve the efficiencies. This is how it looked before, after. Obviously, the before reading of PM 2.5 was 13, 30, 35, 35 because it was a reasonably good site in Chennai. But after the upgradation, client is able to achieve only 2 micrograms per meter cube, which is almost a 90% improvement in indoor air quality. But what happens to the energy consumption? And these are the readings of the energy consumption. So we are usually able to increase the airflows, you can see, by almost 64%. And despite improving the air quality by 94%, one would expect that the energy consumption would grow up, but surprisingly, the energy consumptions also goes down by 64%. And this is a classic case of how things can be achieved if the right technology and the right products are selected. That's all which I had to cover in my session, and I look forward to the rest of the members. Thank you.